we see the achievements as well as limitations. Okay. So he worked a lot for chemistry, no, and he has written books also, organic chemistry books. And at that time, no, people they actually enjoyed chemistry a lot. Well, in his place. His place. It is his place? Okay. And we will honor him, no? You see the modern periodic table, 101st element, the name of 101st element, it is MD. Okay. Find out what is the name of the element. 101, it is to honor Mendeleev. Okay, now achievements we will see. We have seen the tabular column, we have seen groups and periods and how he classified everything we have studied. Now we will see the achievements. The first one is it's a systematic study. No, till now they were not knowing about groups and periods. So now 118 elements are there. In case if he was not able to put this, no, it is very difficult for us to study the physical properties, chemical properties about each and every element and then to remember, no, it will be very difficult. So he has made it very easy for us and it is systematic. Okay, so it is systematic. He has divided into groups and periods and that too based on the properties he has given. Oxygen, with oxygen if it reacts, what will be the formula? If hydrogen reacts with that particular element, what will be the formula? He has made it very clear, so it is systematic, first point. Second point is prediction of new elements. For this also we need guts to predict and tell. So prediction of new elements, he left some gaps in between and he said that new elements will be discovered in future. I told you that three important elements, which are those? Eka boron, eka silicon, eka germanium. No, eka boron, eka silicon, eka aluminium. Eka boron, eka silicon, eka aluminium. Okay, and the names later is given as scandium, gallium, germanium. Right now, scandium, gallium and germanium. Scandium, gallium, germanium. And I also told you that Eka aluminium, now it is called as gallium. No, he has found that atomic mass also. According to him, Eka aluminium, he said the atomic mass of that element which is going to be discovered will be 68. But later, after finding gallium, they were clear that the atomic number is approximately, that is 69.7. So it is near, no, approximate to what he said. So Eka aluminium, then we got a new element called gallium. The atomic mass or the mass number matched. So he is having that power, no, to tell what new elements will be discovered and that too that will have this atomic mass. So the prediction of new elements is an achievement. He left gaps in between and that lead to the discovery of many new elements. Very, very important. If you have left a gap in between, no, automatically people, you are the youngsters, those who are looking into it, no, they will start working on it and many new elements will be discovered. The reason for getting 118 elements is he has left gaps in between and he said that new element will be found and it will have this atomic mass. So automatically people, the new chemists will have the curiosity to get new elements. Okay, so the discovery of new elements because of whom? Our father of which one? Periodic table, Mendeleev. Scandium, gallium and germanium was also found later. So first one is systematic study, second one is prediction of new elements, third one is correction of doubtful atomic masses. See, for example, after giving like this, no, for each and everything he calculated whether the atomic mass is correct or not. What happened now? For beryllium, the atomic mass was given as 13.5. Okay, he thought that this is wrong and then again he calculated it and then he got it that first it was coming under 3, valency was given as 3. But later after calculating it, he found that the valency will be 2 and he corrected and he kept it particular place. So correction of doubtful atomic masses. Whichever he feel it is doubt, what he did? He calculated it again and then he corrected the valency. For example, beryllium's valency was 3 and then it's corrected to 2. It's very important. So 3 achievements, very important. First one, it gives a systematic study. Second one is he started predicting that new elements will be formed, and for example, eka boron, eka silicon, eka aluminium. Later, we got new elements in that place, that is scandium, gallium and germanium. Correction of doubtful atomic masses, for example, many are there. For example, beryllium, it was given as 3, the valency was given as 3, but later he found that the valency is 2 and he placed that in that particular place. Okay, whatever it may be, some limitations will be there. People will start telling, this is not correct, that is not correct. We will see what are the limitations in his periodic table. Okay, the first one is position of hydrogen is not satisfactory. See, position of hydrogen is not satisfactory. In the modern periodic table also we will be studying clearly about the position of this. What happens now here? Hydrogen is placed near lithium, sodium, potassium. These are all one group, okay? Alkaline metals or alkaline earth metals? Alkaline metals, okay. Here, this is coming under this. Now, all will have, because of 1, it is having 1. So, for lithium, what is the atomic number? For sodium, what is the atomic number? For sodium, the atomic number is 11. Now, we are splitting it based on the atomic number. But here, we did according to the atomic mass, right? So, hydrogen is placed here, that is not correct according to the other chemists. Hydrogen is not correct, given a correct place, because halogens, which are halogens? Chlorine, fluorine, bromine, they all, what is the importance of halogens? What will they do? They are non-metals. Hydrogen is also a non-metal. In carbon chapter we have studied, no? They react with hydrogen or hydrogen react with them, and the bond which is formed between them is covalent bond. So according to them it should be placed with what? Halogens. But it is placed here. So the position of hydrogen is not satisfactory. It can come in the first group or it should come in the halogen group. But how particularly you have put it in the first group. Anomalous position of some elements. Okay, position of some elements here it is not very clear. See here I told you this example now. In transition series, iron, cobalt and nickel he has placed in one group. Okay, transition series, iron, cobalt and nickel, and we know that he has arranged according to the atomic mass. In that case, 55.85, 58.93 and then he has put 58.7. It should not come like that, no, this should come first. Same like this, there are many other elements also. So, anomalous position of some elements. They were not very clear where to put. Position of isotopes. What do you mean by isotopes? Definition, can you recall? Position of isotopes? Same atomic number but different mass number. Right? Okay. So, here atomic number, what is the atomic number of hydrogen? 1. So, in case in the modern periodic table, if you are putting hydrogen in the first place, it is acceptable because it is having atomic number 1. But here the mass number is different, no? 1, 2, 3. When you study about the isotopes, I think you have studied the examples. Hydrogen as well as chlorine. For chlorine, 35 and 37. No. For this hydrogen, 1, 2, 3. Protium, deuterium, tritium you have studied based on the number of neurons, right? Neurons or neutrons? Okay. Neutrons. In the neutrons, what is there? 1 will be there in first one, 2 will be there in second one, 3 will be there in the third one. What is first one? Protium, deuterium and tritium. So position of isotopes also it is not mentioned here. They have just given it as hydrogen. How is it possible? Fourth one is no correlation of elements in subgroups. I 6, 7. All are having subgroups. A, B, like that. Only the 8th group is not having, right? So A, B, when it is given, there should be some relation, no, between how can you put some elements in A and some elements in B. See, for example, they have given lithium, sodium, potassium. Lithium, sodium, potassium, all the three are coming under first A. But copper, gold and silver are coming under first B. There is no correlation. Okay, what is the relationship between this and this? So there is no correlationship. That is also a limitation. Different groups for different elements. See, for example, copper and mercury they have given. Copper and mercury resembles in many characteristic features, but copper is given in first B and mercury is given in second B. Why it is given like that? That is also a question mark. Cause of periodicity. What is periodicity? Periodicity means repetition of elements. After some elements, some repetition is happening. That is the reason he placed like this. But he has not given the reason why that repetition is happening. Okay. So why it is repeated, the reason is not given. So that is also missing. So here achievements, if you see 3 achievements important: systematic study, prediction of new elements and correction of doubtful atomic masses. So these 3 are achievements. Whose achievements? Mendeleev's achievements. Limitations, if you see, there are 6. Position of hydrogen is not satisfactory. Anomalous position of some elements, and then position of isotopes is not very clear. No correlation of elements in the subgroups. Different groups for different elements that he has not given it, the reason is not given. Cause of periodicity is also not clear. So these are the limitations of Mendeleev's periodic table. Okay, so the next one is modern periodic table. We will see who gave the modern periodic law first and how the modern periodic table at present what we are using now came to us.